Here we've got a guy who is zipping around because of this rocket. Now this 300 meters per second, or whatever your velocity is, that is the velocity of the gas escaping the rocket. So really we have a mass concentrated on the edge of a circle. So the moment of inertia of this guy is just his mass. For me it's 240 kilograms, and it's going to be mr squared because all the mass is on the outside of the circle. So when it asks for the moment of inertia of the rider, box, and rocket about the pole, that's going to be mr squared. The rocket develops a thrust perpendicular to the path of the rider. What's the angular acceleration? Well, that many newtons, it's going to give me a torque. And if I want my acceleration, I know that just like F equals ma, I know that torque equals I alpha. So you're looking for alpha here, and you know the moment of inertia from the previous problem, and they give you the torque, and the torque is going to be actually Rf. So you know the force that it is pushing with, which is 75 newtons. That's my force, and the radius, of course, is for me 4 meters. So you've got Rf, and you know I, and you're looking for alpha. Next, it says after what time is the rider's velocity equal to 10 meters per second? It helps to know some equations of motion. So by this time you know alpha, you know that your initial velocity is going to be 0. You're looking for where your final velocity is what was given. For me it's 10 meters per second. Actually, meters per second would not be omega, it would be a velocity. So it's 10 meters per second is my velocity, but if I take that and divide by radius, then I get my final omega. And after what time? So you're looking for the time. So you need an equation with omega 0, omega, alpha, and t. And I believe that is just that your acceleration is your change in your velocity, your angular velocity over time. So solve for time. Next problem.